Today, we're going to talk about something that's absolutely critical in machine learning, but it's not always the sexiest part. We're talking about the journey a model takes from being just code on a laptop to actually working out there in the real world. We're talking about the ML pipeline. So, imagine this. You've done it. You've built this amazing AI model, you've tested it, and you finally pushed it into production. But here's the question that should probably be keeping you up at night. Is it already starting to fail? Because, and this is the part so many people miss, getting a model live isn't the finish line. Nope, it's actually the starting gun. The second dot model is out in the wild, it starts getting hit with all the chaos of the real world, and that's when the really hard work begins. Right, so let's talk about this ticking time bomb. Why do so many promising, powerful machine learning models just fizzle out once they're actually in production? The number one enemy here is something called model degradation. See, a model is trained on data from the past. It's like a snapshot in time. But it has to make predictions about a world that is constantly changing. So over time, the model just gets stale. It gets out of sync with reality, and its predictions get worse and worse. And when a model starts to go bad, it's usually because of one of two hidden villains. First up, you've got data drift. This is pretty straightforward. The data your model is seeing now just looks different from the data it was trained on. Think about a fraud detection model trained before 2020, suddenly having to deal with the explosion in online shopping. The data has drifted big time. Then there's concept drift, which is a little sneakier. This is when the meaning behind the data changes. For instance, what makes someone a low-risk borrower might be totally different during a recession than during a boom. The data points might look the same, but the concept they represent has completely changed. So how in the world do you fight back against this constant decay? You don't do it by hand, that's for sure. You build a machine to do the fighting for you. Think of it like an assembly line for your AI, a totally automated pipeline that keeps your models fresh and running strong. And this right here, this is basically the blueprint for that assembly line. You can see it's a complete loop, an end-to-end system. It all starts with your code and your data, which get fed into the ML pipeline for training and testing. Then it moves into deployment, and right after that, continuous monitoring kicks in. It's a full life cycle, not just a one-way street. We can really break this whole thing down into four main stages. First, you've got to get your raw materials in order. That's data ingestion and preparation. Second, the assembly happens. You train and validate the model. Third, you ship the product. You deploy it. And finally, and this is maybe the most important part, you have the quality control department, constant monitoring and maintenance. It's a loop that never, ever stops. Of course, every assembly line needs its machinery, right? And in the MLOps world, you've got some great options. If your entire world is built on Kubernetes and you need massive scale, Kubeflow is probably your best bet. If you're really focused on tracking all your experiments and want something you can pick up fast, MLO is fantastic. And then there are really cool tools like ZenML, which are built for pure flexibility, helping you go from coding on your laptop to a huge cloud setup without all the headaches. It's all about picking the right tool for your specific job. Okay, but before we go any further, we need to talk about the absolute foundation of this entire system. You can build the world's greatest assembly line, but if you're feeding it garbage raw materials, you're going to get garbage products. This is where data governance comes in. It's the rulebook for quality and safety for all of your data. And this rulebook is built on a few really key principles. You have data quality, making sure your data is actually accurate. Privacy and security, well, that's pretty obvious. You have to protect this stuff. Then there's data lineage, which is super important. It's the ability to track your data's history, where it came from, what's been done to it. It is a lifesaver for debugging. And finally, you have accessibility and compliance, which is all about making sure the right people can get to the data they need while making sure you're following all the rules. I know, this all can sound a little, abstract. But when you put it all together, great data governance in an automated pipeline, the results are just incredible. So let's make this real. Let's look at a case study from a fintech company that did this right. So first, check out this number. By automating their data pipeline, they cut the time their team spent just preparing data by 85%. An 85% reduction. All of a sudden, their super smart, super expensive data scientists could stop doing manual data cleanup and actually start, innovating. And then there's the speed. Before, when they needed to retrain their fraud model, it was a painful 2-week-long process. With the new automated pipeline, just 2 hours. I mean, think about that. They can now react to new fraud tactics almost in real time, instead of being 2 weeks behind the criminals. That's a game changer. And here is the bottom line, the number that really matters to the business. Better data, faster cycles, it all led to a 27% jump in how accurately they could detect fraud. That's not just some tech metric. That's real money saved, right there. Okay, so our assembly line is up and running, and it's churning out fantastic results. But how do we make sure it stays that way? Well, we need a quality control department. And in the world of MLOps, we call that model monitoring. Now, monitoring isn't just one single thing. You're really keeping a close eye on 3 different areas at once: the integrity of the data that's coming in, the performance of the model's actual predictions, and the overall operational health of the system it's running on. Let's break those down. First, you've got data integrity. This is all about checking your raw materials on the fly. Is the data that's feeding the live models still clean and consistent? Are we suddenly getting a bunch of weird, missing values? Any of that could be a red flag that something broke upstream, and it'll wreck your model's predictions. Second, you're tracking the model's actual performance. You're constantly asking, is this thing still making good predictions? You're looking at metrics like accuracy and precision to see if the model is still doing the job you built it for, or if that pesky drift is starting to creep in and ruin the results. And last but not least, there's operational health. This is about treating the model like any other piece of software. Is it fast enough? Is it a memory hog? I mean, a model that gives you a perfect prediction but takes 10 seconds to do it? Well, for most real-time apps, that's completely useless. This whole field is just moving at lightning speed. So as we start to wrap this up, let's take a quick look ahead. What's next for the AI assembly line? We're seeing a few really interesting trends. First, something a little meta: AI-driven governance. We're literally starting to use AI to help manage and monitor other AI systems. We're also seeing regulations start to catch up, which is going to demand pipelines that are way more robust and transparent. And finally, we're seeing this move toward integrated governance, where you stop thinking about data and models separately and start managing them as one unified system. Because really, you can't have one without the other. And that leaves us with one last pretty big question to think about. As these AI assembly lines get smarter, more powerful, and more automated, running with less and less direct human oversight, who's on the hook when something goes wrong? Who is ultimately responsible when it fails? It's a huge question, and it's one we're all going to have to figure out together. Thanks for joining me.